Okay, ladies and gentlemen, this is the final stages of the life of this decommissioned magnet. The reading is minus 1.6% helium. So over on our ammeter gauge it says 0 current. The voltage across the coil has dropped to 0. I left the room for about an hour and came back, and this is what I found. However, we still have some positive sign. 3.8 ohms on the PT100. So we still pretty much have superconducting temperatures in there, which means we can do one more final experiment. And that is, can I charge this magnet up to give it some amperage? Can I restore it to have some coil current in there? Well, let me put this on a tripod. Master my tripod skills. There we go. Alright, I am going to turn my power supply on. Power supply is on. On my little switch there, it's a little bit far away, but from the other shots, this is the main switch. I'm going to turn it on, which allows a section of that main coil to become non-superconducting. A little resistor next to it. It's going to heat it up. That's what the main switch does. It's powered like a 9-volt battery. Oh, look at that. I now have some voltage across the coil. You know what just happened? And now I have 0.72 amps. You know what just happened is this thing dropped its voltage so much that there was not enough voltage to keep the current coming out, and it returned to being a superconductor at the level of 0.72 amps and dropping. Great. So now I'm going to add some voltage back into it. So I'm going to do this with my little fancy resistor, homemade resistor. Every time I wrap a coil or a half coil of this stuff, half an amp. Alright, let me unwrap it. Now on this, okay, I'm going to take this off the tripod. On my voltage across the coil, 0.1 volts. Now notice it changed direction. I'm also down to 0.3 amps. Notice that's a positive voltage, 0.57 volts. I'm gonna wrap some of this on there, 1/2 of a turn. Notice the direction of the voltage change. It just went negative, the opposite direction. That means we are charging. Notice our amps went up to 0.74 amps. But you know, oh yeah, that makes sense. Now as it drops, well, 0.478, 0.78. Okay, now notice this resistance here, this voltage is dropping. That means it's time for me to do another bump in the current flow through that magnet. So I'm going to go boing and look at the voltage. It just jumped up to minus 1.3. So I am now charging that coil. We are up to 1 amp. And that is with the main persistent switch passing resistance current, keeping it hot. So now it says, we say the persistent switch is open because it's no longer superconducting that section. Alright, our voltage has dropped to minus 0.3, so it's time for another winding. This time I'm going to let the camera stay on the winding voltage, the current, the main coil. Here we go. There, I just did it. It went back up to 1 volt. There may be some fluctuation as these fine wires, actually there's a loose wire there touching back and forth, which will mess things up. I'm going to put the camera down here and get that out of the picture, out of the way, so we won't get random readings. Alright, I'll wrap that out of the way. Okay. Alright. Minus half a volt. Time for another wrap, which will increase the current. There, half a wrap is a half an amp. We're now up to 1.97 amps. And there, the voltage across the coil has jumped to 0.9 and falling, 0.8, 0.7. And we're going to do another wrap. So we are letting more and more current, because we're lowering the resistance by adding more of these wires, more and more current to go through that coil inside the magnet. The big 770 Henry, it used to be 7 Tesla, right now it's a lot less Tesla because it depends on the current. And we're up to 2.5 amps through that coil. Minus 0.74, I guess that's about, let's let it go down a little bit. It's time for another jump. Watch it jump. Okay, wrapped once. It went up to minus 1.1. Now let's, just for the fun of it, wrap it again. Oh, we went up to minus 1.38. So definitely made a big jump. The current is now at 2.9 amps. Alright, let me, I had a little trouble here with my wrapper. There, I'll wrap it again. Minus 1.3. 3/10 of an amp, or 3 amps. And there's my little resistor setup. Okay, I better wait for this to drop. Well, let's try to, stress the system. What happens when I wrap it? So I'm going to wrap another winding. We jumped up to 1.28. Not too bad. Let's do another winder, and we get that to jump to 1.5. Okay. 3.8 amps. 3.9. Okay, we're growing. 9.799. 4 amps. So we're definitely charging this magnet. And we have our main switch is still on. And there's the helium loss. I don't see too much helium loss. That means we're probably getting pretty low on helium. Alright, minus 0.8. Time for another wrap. Wrap it once. We jump up to 1.1. And since we're just looking for some shocks to the system, I'll wrap it again. 1.28. And we're at 4. Let's see how the amps climb. 4.78, 4.8. Because we're fighting 70 henries of inductance, which means the current is slow to change because you're growing a magnetic field as the current grows. The growing magnetic field in the theory of inductors then fights the current trying to increase. Oh, up to 5 amps. And we're down at we're at 0.8, so it's time. Can do another wrap. We'll wrap it once, and we're up to 1.07. We'll wrap it one more time, 1.28. And let's watch the amps increase. 5.4 amps back into the magnet coil and rising. 5.5. So basically what this is meaning is we basically have about 1 volt in the charging direction, which shows up as a minus on my meter. 1 volt of electricity to raise the amperage. 5.78, 5.8, 5.83. And so I'm going to do another wrap so I can increase the current flow. 5.9, 6, 1 volt across the coil, 0.9 volts. Okay, I just did a wrap. And let's wrap again. Get a nice 1.3 volts of charging voltage. And let's see how high we can get that. When you wrap it one more time, it shoots up to 1.4. Yeah, I won't try to stress the system too much. The recommended maximum. Alright, let me put this down. I did an extra wrap. It's at 1.46. Let me set this down for a sec. And look in the book to see what kind of recommended charging levels we can get. And I should have bookmarked my pages, but I didn't. See if we can find procedure for shimming. Okay, we think we're in the right spot. Here we go. So we have if we have 0 to 75 amps, sweep rate is 1.2 amps per minute, a coil voltage is 1.4. So we've been keeping it a little bit below 1.4 most of the time. So let's look at the coil voltage down to 0.9, and our amperage is up to 7.49, and it is growing. It is growing. So now if we look at the official charging technique of a superconducting magnet, we have a region where we can charge it at the faster rate, which is 1.2 amps per minute, and then as we get to around 75 amps of charge, then we should lower our speed. We should drop the coil voltage to only 0.7 volts. Like right now it's 0.63. We should keep it below that level. And here you can see the slope of the hill has decreased in that section, and then they decrease it one more time. Now notice they purposely go over the recommended number of amps so that they can then bring it down, home it in. So they call that overfield, and they can home it in to get to the desired quantity. So that's your charging instructions for this particular magnet. Okay, what are we at amp wise? We're up there at 8 amps, and let's try to bring this to 10 amps before we can shut her back down. Just to show that we put 10 amps back into this current. 89 amp is the official level, but that might take a while. Plus we're kind of risking it. We're very low on helium there, and nobody wants to pay $10 a liter to add 100 liters to this machine. Alright, so 0.36, I'm going to do a wrap, and while you watch the screen there, you can see the wrap increasing that. One wrap, another half wrap. We're up to 0.87. It didn't jump that much, did it? So let me try to do another half wrap. And now we jump to 1 volt. Another half wrap, we jump to 1.1. What's happening to our current here? Our current, now on this little meter we have several numbers. The only valid number is the current one, so 8.86.